In this video we are going to talk about the diesel side stripper and the bump around. So this is our atmospheric column, and we mentioned before that we have off gases or light gases, naphtha, wastewater. Here we have also kerosene, diesel, and atmospheric gas, oil, and atmospheric residue. We haven't added diesel and kerosene, so now we are going to add diesel. Double click here to open our column environment, and at the top we will find that we have a side operation here. This is the section that we are going to add the side stripper and the bump around from. So now we are going to add at the beginning our side stripper. So choose the side stripper and press add. After pressing add, this page will open. So we are going to add the information here. So here we are separating diesel. So this is a diesel side stripper, and we are removing it or drawing it from tray number 17, and it will be returned back to tray number 16, the one above it. Okay, so 16. So here also we are working with stream stripped. So we mentioned before that we have two types of side strippers. It could be reboiled or steam stripped. For EGO and the diesel, we are going to have a steam strip. Next video we are going to add a reboiled side stripper for kerosene. This is our steam feed, so we are going to call it diesel steam, and later on we will define this material stream. Also here we have a flow basis. This is the flow basis. We are going to choose a standard ideal volume. So this one is a standard ideal volume, and this information must be given. You can't assume it. For the product stream, here we are going to, the product is our diesel product. Okay, we haven't added it, so we are going to add diesel here. Okay, we are, okay, they added it. So we are going to close this one and again open our side stripper. Here we have outlet flow. We are given this amount, so we need to view it. View this one. We have diesel product from SS, and we know that this value equals, we are given it to 130, so we can add it from here, or we have another option to add it. This is like the outlet flow or the draw flow. And again, what else we have? We can go here, and we have inside this one. Okay, we need to go inside, enter the flow sheet, and after entering the flow sheet we will have the EGO and the diesel. Now I need to add information related to the diesel. Okay, it's a little bit crowded, but this one is the diesel. I know here that the draw flow rate, here we are giving it with volume, standard ideal volume. Okay, and it's given to be 130 meter. Okay, it's unknown composition, and it will actually, we need to define more information to it to be available. Okay, here we have to go back and open our column to add the side stripper. Okay, if we go to monitor now, design and monitor, you will find that out the degree of freedom is 0 even, but it's not converged because here you need to enter some data. Okay, we are going to add the bump around at the beginning. So bump around, it shows it from here, and you are going to add it. This is our diesel pump around, so you need to define the product at the beginning because you have different products here. We are, as we mentioned before, we remove it from tray number 17 and we cool it, lower its temperature, and return it back to tray number 16. Okay, so here you add the pump. Okay, bump around, you can add a bump or without adding a bump. In this case, it's optional. So the bump around we have located for the diesel draw, and we have entered the information that we need. So no more, we are going to install it. Okay, so now we have, after installing it, you will have these options at the top: two active option or two active specs. The first active spec is bump around rate, and second one is the bump around duty. Okay, this is the duty and this is the bump around rate. Okay, in this case you might be given one or two of them, and to modify or enter the data that is empty here, you double click here so it's open like this one. Okay, we are given here that the bump around rate value is 200 meter cube. So we have a flow rate of the diesel bump around rate, and we have fit, as I mentioned before, 200 meter cube per hour, so it's not molar, it's a standard ideal volume, and its value is 200 meter cube per hour. So this is our first value. The second value is related to, we close this one and we need to add this one, the second spec that we had. So double click here and we will have this page. It's about the duty of the bump around. In this case, the bump around duty must be in joule. Okay, so we are going to add the duty, but here the spec type is a temperature drop, so here we are going to choose the duty, and we are given that the duty equal negative 3.693 E with the power 7, okay, kilojoule per hour. So this is our values of the duty, and we are going to close this one. Now if we go back, we have here EGO bump around and diesel bump around. So now we are going to check, we have entered the data that we need, so here we are going to try to converge this column. But before, I mentioned that I added a diesel steam. Okay, so we need to click here and we look for the diesel steam. Okay, so diesel steam. Okay, this is the diesel steam. Here I need to add the information. I'm sure that the composition is water and the water should be 1. Okay, so water 1, and okay, so now I have added the temperature. Also I am given a conditions for the diesel steam, like the temperature here is 150 degrees Celsius, the pressure is 345 kilopascal, and the mass flow, this one, the mass flow is 1361, and I've entered the composition, so now we are okay. Now it's red, so we now need to go to here and go to our monitor, the design and monitor, and organize our here variables or spec, because we want the degree of freedom to be verified. Okay, so in this value we don't have the reflux ratio, we have this value, so we make sure it's active. We have this vapor rate, so we make sure it's active. Again, we have AGO product flow, we have entered it to be 30, and for AGO bump around 200, and again it's active. We have added also AGO bump around duty, and it's active. We have here diesel side product side stripper product flow. We have this value, we have entered, actually we have to edit here, and the pump around rate. Okay, this is the side stripper rate. Okay, for the side stripper rate I'm going to look for the value, and it's 130. This one is 130, and it's active. Okay, so now if we run, it must be converged. Okay, so now it's working because we have entered all the data that we need. Okay, I need to go back to okay, let's check as a beginning. You will find out that here the current value is equal to the value that we enter, but here for the vapor rate that we enter to be 0, it actually has a value. Okay, so now we have our side stripper and bump around of diesel added, and we have checked our monitor to make sure that the degree of freedom is equal to 0. Always go to the performance to check what you have. Here you will have atmospheric feed, bottom steam, diesel steam, and EGO steam. So this is the material or the feed that is entering the column. What is getting out from the column? We have off gas, naphtha, wastewater, atmospheric residue, diesel side stripper and EGO product, or this is also the diesel product, okay, but we're removing it from the side stripper. This is the flow rate of each one. Also, you have here some information about the draw, okay, and for the condenser and the reboiler, we have here a partial condenser, and we haven't added a reboiler in the bottom. You can go to the sheet here and check the internal streams. Okay, you haven't added this internal stream yet. Okay, so here you will have the flow sheet. You have the main the number of stages. What's happening is this is the number of stages for the side stripper, and this is another side stripper, so the number of trays. So if you are asked about the total number of stages, it's 20 to 29 inside the main column, 3 for the side stripper, 3 for the other side stripper. The condenser, because it's partial condenser, it's considered one tray, and we don't have a reboiler, so it's 0.